All right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it for today. This is the last thing on inequalities, and I might have said that last time, but I didn't realize there was another one because it doesn't really get any more complicated solving-wise to do the last thing that we did, which was compound inequalities. But this one is kind of different because it involves absolute value, and it is a little tricky, but we're going to go through it a little bit slowly at first and then kind of pick up as we go, just like we normally do. And I'll show you guys how to do this pretty easily here. What you want to do, and if you notice, all the questions that we can see so far, everything is inside the absolute values, the little bar things. They're like parentheses, but they're not curved. They're like straight parentheses. So everything so far is inside of that, except for when we get to the second page here. And then there's some stuff that's not inside the absolute value. So when we get to this, we're going to need to kind of solve everything that's not in the absolute value first, then split it. So really, we want to get the absolute value by itself first. It already is for the first page here, so we don't really have to worry about it. But on the next page, we'll kind of come back to that. But we already have everything that's next to the absolute value. Everything that's on the left-hand side is inside the absolute value marks. So we want to split it into two equations. We want to go like this. N over 4 less than or equal to 3. So in one of these equations, you just get rid of the absolute value. You just get rid of it. Nothing happens. Everything stays the same. Okay, that's the first option. All right, so you want to split. When we split, one of them is exactly the same. Exactly the same. But with no absolute value. But no absolute value. All right, that one's the easy one. And the reason why is because absolute value makes whatever's in the parentheses positive. So if we assume, like, hey, it's already going to be positive, then nothing would change. If n over 4 is already positive, then nothing would change. It would just be n over 4. So no big deal. But if n over 4, if n happens to be like a negative number, then it would end up being the positive. It would be the opposite. So you could either make that negative, or you could make the other thing negative and switch the sign, which is usually better. So n over 4 could be negative before we flip the sign. So then what we would want to do then is, what I prefer to do is you keep the absolute value stuff the same. So keep the absolute value stuff the same. Then you want to switch the sign. Switch the sign. And the sign, actually, you know what? Let me word it like this. You want to switch the sign of the inequality, and that symbol means and the number. All right, so let me show you what I mean. So keep the absolute value stuff the same. N over 4. Switch the sign of the inequality, so now it's going to point this way. Right? It was pointing the other way. Now I have it flipped. Switch the sign of the inequality. Inequality. And the number. So now 3 is negative. And there we go. All right, so that part was a little bit more tricky. But you basically, it's sort of like keep, change, flip almost. So if you remember keep, change, flip from when you had to divide fractions, when you're dividing fractions, you keep, change, flip. Sort of the same thing here. You keep, change the inequality sign, and then flip the sign of the number that it's equal to. Okay, so it's basically keep, change, flip, but for an inequality. Okay, and then we solve. So if we solve, we just multiply by 4, multiply by 4, n over 4 means n divided by 4, so we're going to do the opposite. The opposite of dividing by 4 is timesing by 4, so we times by 4 on both sides. N is less than or equal to 12. 3 times 4 is 12. Right? I kind of had to squeeze the 4 in there, so it kind of looks like a power, but it's not a power. I'm multiplying the 3 and the 4. Okay? I just kind of had to squeeze it in there because I didn't leave myself enough space. And then in this other one, I need to do the same thing. So 4 cancel for the exact same reason. And then I have n is greater than or equal to negative 12. Now you're probably thinking like, oh, I just multiplied by a negative. Well, I did. Negative 3 times positive 4. I'm multiplying 4 by negative 3, but I didn't multiply a negative number on both sides. I multiplied by positive 4 on both sides. So careful with that. You do want to remember to flip the sign if you multiply by a negative, but only if you multiply or divide by a negative on both sides. Okay, so when we solve it, we get the same thing. We get either 12 or negative 12. So then we basically graph its solution. So n has to be less than or equal to 12. Here's 12. The or equal to means closed circle, right? And then if it doesn't have the or equal to, it's open circle, right? So keep that in mind. And it has to be greater than or equal to negative 12. So it's actually only going to be what's in between, because if we think about it, n over 4, let's say n is like 400. Okay, well, if n is 400, 400 divided by 4 is 100, which is way bigger than 3, but it has to be less than 3. So if I need an absolute value to be less than a certain number, then my solution is going to be kind of limited. I can only plug in numbers for n that, when divided by 4, and then I take the absolute value, it's going to be less than or equal to 3. So kind of limited in what my answer is here. All right, number 2. Let's try this again. So it's got a negative. We don't just get rid of the negative, though. We have to be careful. You do get rid of the negative if you plug in a number for v. Let's say I plug in 1 for v. 1 times negative 9 would be negative 9, and then the absolute value, that would be positive 9. But I don't touch the negative. I don't just get rid of any negatives I see inside the absolute value. You just follow the steps. Okay? One of the things about math is sometimes you think something makes sense because you're like, oh, absolute value, it gets rid of negatives. And it does. But when you're following a step-by-step process, this is why I like to make steps for you guys. When you're following a step-by-step process, don't deviate. Math is very unforgiving because you can be like, oh, this should work for this, and then it doesn't because you were thinking it would apply to this thing, but it didn't, and it's really frustrating. I know, but I'm creating these steps for you guys so that when you follow the steps, you get the right answer. Okay, so number 1. Exactly the same, but no absolute value. Okay, so I'm just going to write this. Exactly the same, but no absolute value. Okay. Actually, you know what? Let me erase this and move it over a little bit because I'm going to need some more space. So I'll make a little border right here and right here. So negative 9v less than or equal to 54. All right. And then step 2, keep the absolute value stuff the same. All right, so keep, switch the sign of the inequality, change, flip the number, flip, keep, change, flip. And then we solve both. We want to divide by negative 9 in both cases. So notice the steps are always the same. It's just sort of like it's equal to plus or minus sort of thing, but you also have to flip the sign. So you do want to solve 2 different equations. You don't want to try to solve it as one equation. It would be really weird. It's possible, but it would just, I don't know, it'd just be kind of weird. Unless you just really got the hang of that method or whatever. So in this one, in number 2, I am dividing by a negative on both sides in both equations. So I do need to flip the sign. Right, so I'm going to flip it. Positive 54 divided by negative 9. So positive divided by a negative is a negative. Then 54 divided by 9, which would be 6. Okay, That's going to cancel again there. V is less than or equal to. Sign flips. I did have to flip it already to set up this equation, but I'm just following orders, right? So if I divide both sides by a negative, I have to flip the sign. So it kind of flipped back to what it was, but that's fine because that's what I'm supposed to do. And then here, a negative divided by a negative is a positive. And then again, 54 over 9, which is 6. Right? So V has to be greater than or equal to negative 6. Greater than or equal to negative 6. Less than or equal to 6. So notice it's only what they have in common. Because technically, if I were to graph this, and we kind of talked about this last time with compound inequalities, which is why absolute value inequalities comes after compound inequalities, because this is basically a compound inequality. It's an and. It's only what they have in common, because if I graph v is greater than or equal to negative 6, then technically any value greater than 6 would work as well, because like 10 is greater than or equal to negative 6, right? But if I try to plug that in to the equation, to the inequality, it wouldn't work. If I try to plug in 10, that is. If I plug in 10 times negative 9, if I plug it in, would be negative 90. The absolute value of that is 90, which is not less than or equal to 54. So it doesn't work. So this is basically an and. If you didn't see that video, by the way, on compound inequalities, or if you don't know what I'm talking about, an and versus an or, go check that out. At the end of this video, you should see a link for that playlist, and you can watch the last video in that playlist. And actually, I'll probably have that be the recommended video as well. So you'll be able to see that in the left or the right-hand corner towards the end of this video. So if you haven't seen that video, go check that out. But that's what I'm talking about, and versus or. This is an and compound inequality. Okay, so just like I promised you, we're going to start to speed up a little bit as we go in increments, and then I'll just, I'll kind of go a little bit slower on the second page for the first couple as well, because they're a little bit different. You have to do a couple pre-steps before we do what we're doing right now. Let's go ahead and solve this. So this would be keep it exactly the same first, then do keep change. Oh, sorry, I didn't change. I said change, but I didn't. Go back here. Keep change flip. All right, multiply everything by 6. 6, 6, 6. A little divider right here so I don't get those two mixed up. That cancels, that cancels. X greater than or equal to 30. X less than or equal to negative 30. Oh, that's kind of interesting. This one ends up kind of working out like an or, because technically, if I have less than or equal to negative 30, that would be like this, and then greater than or equal to 30 is like this. Now, if this was an and, because I told you on number 2, that one was an and, it's only what they have in common. This one actually works out like an or, because if I take the absolute value of a number and it has to be greater than 5, x has to be a really big positive or a really big negative. If it's a really big negative, I take the absolute value, it ends up being a positive number. So it's bigger than 5. Let's say x is like 60, right? If I plug in 60, 60 divided by 6 is 10. Absolute value of 10 is, well, 10, which is greater than 5. If I plug in negative 60, I get the same result. Negative 60 divided by 6 is negative 10. The absolute value of that is 10, which is bigger than 5. So any really big negative or positive number is fine. Works out like an or. I kind of have two separate answers. So that's the pattern. If you notice, number 1, number 2, they're both less thans. So it turns out to be an and, only what they have in common. Whereas number 3 was a greater than sign. So it turned out to be an or. And that's going to be a theme that stays the same throughout these problems. Okay, so number 4, keep it the same. Then keep, change, flip, divide everything by negative 6. Negative 6, negative 6, all over the place. And then B, I have to switch the sign because I'm dividing by a negative 6 on both sides. So divide, sign changes, Positive 60 divided by negative 6 is a negative, right? So positive divided by a negative is a negative. 60 divided by 6 is 10. Here, same thing, except besides switching the sign, I have a negative divided by a negative this time, which is a positive. So b is greater than or equal to negative 10 and less than or equal to 10. Since this was a less than sign, it's what they only have in common again. Okay, it's an and. It functions like an and compound inequality. All right, so this one's an and. Right, that's an and. Oh, look, an or. There's an or. Right, and I'm using the same color here, but I want to switch colors, actually. I usually switch colors every 2 problems. So let's go ahead and do that. And this is no different than the ones we've already been solving, so I'm going to go a little bit faster now through these. Okay, keep it the same. Keep, change, flip. Divide. Negative 8, negative 8, negative 8, negative 8. In greater than negative 4. In less than positive 4. Okay, so less than positive 4. Greater than negative 4. Only what's in between. Just like that. And I've said this before in other videos, but if this is your first video of this series, then just remember, you are definitely okay to skip forward to a harder problem. If you're having to work this out for a worksheet in class, and you're just kind of looking for the answers to hard problems, and you're stuck on, like, let's say number 11, just skip to number 11. I don't mind, really. Because at this point, nothing is new on this page. I'm just going to solve these out pretty, a little bit faster and then get to the next page. So if you're, looking for the answer to number 6, you're just waiting for me to shut up at this point. But if you're looking for the answer to number 11, you can go ahead and skip to that problem. Okay? So keep that the same. And, I had a timer on my watch that I forgot to turn off. So keep it the same at first. Then keep, change, flip. We want to subtract 5 on both sides. This is going to be 4. If I subtract 5 from negative 9, I get negative 13. Because I have 2 negatives, so I'm adding. So greater than negative 13, it's right in between. And then 4 is right here. Okay, so it's in between those two. And there we go. All right, switching colors again. 4v minus 9 greater than or equal to 27. Keep, change, flip. All right, and we're going to solve it the same way. So I'm going to add 9 to both sides. 4v, 36. Add 9 to negative 27, so I'm actually subtracting. 18. Divide by 4. All around. V is less than or equal to 9. V is greater than or equal to negative 9 halves. Okay. Greater than or equal to negative 9 halves, that's negative 4.5. So that's like right here. Right? Kind of a weird number, but if we think about it, let's if we want to check it, we plug it in, right? So check it by plugging it in. 4 times negative 9 halves would be the same thing as 2 times negative 9, which would be negative 18. Negative 18 minus 9 would be negative 27, and then I take the absolute value and I get positive 27. So look at that. That was the right answer there. So I did all of that in my head, so if you weren't following me, that's okay. All I'm saying is that if you want to check your answer, if your answer seems off, because it kind of did a little bit. I was kind of second guessing myself on that one because that was a negative fraction. I haven't gotten a fraction as an answer yet. If you notice, all of our answers have been positive or negative whole numbers. So getting a fraction, I was a little bit hesitant, like, oh, maybe I did mess something up. But then I plugged it back in, and it worked. The inequality worked when I plugged it back in, so I'm okay. All right, so you might have to write that out off to the side a little bit of your scratch paper. Just add that in there and check it by plugging it back in. But I highly recommend plugging in at least the harder questions on a test or a quiz, like plugging it back in to check to make sure you got it right. Because it's easy to miss something by just, dividing by the wrong number or missing a sign somewhere, right? There's a lot of little things that you can miss. And if you miss one little thing, it's the problem with math. You miss one little thing and the whole problem's wrong, right? So go back and check it, especially for the harder questions on a test or a quiz. Highly recommend. But anyways, back to here. Less than 9. Here's 9. Less than or equal to, sorry. So it's in between. And there's the answer to that. 10 plus 4x less than 14. 10 plus 4x, switch, and that's negative. So we're going to subtract 10 on both sides. Subtract 10. If I subtract 10 from a negative, it becomes more negative. Then if I divide by 4, I get 1. Divide by 4, I get negative 6. So greater than negative 6, less than 1. Right in between, just like that. All right, on to the next one. Okay, we have 3 minus 9a is less than or equal to 60. 3 minus 9a, 60. Keep, change, flip. So we want to subtract 3 on both sides. Subtract 3. Okay, and then subtract 3 again. Notice the steps are always the same. Subtract 3. Then I divide by negative 9. Divide by negative 9 all around. I'm going to have to flip the sign since that was negative. That's not going to be as nice of a number as the other one. It does simplify a little bit, though. Let's see. 57. 5 plus 7 is 12, so 57 divides by 3. It's 3 shy of 60, and 3 times 20 is 60, so that would be 19. So negative 19 over 3 looks like what that simplifies to. And we could check it by multiplying 19 by 3 again if you want, or if you already did this by doing division off to the side. If you're not allowed to use a calculator, then don't worry about it. But I just kind of did that in my head, so whatever. Negative 19 thirds. Negative 18 thirds would be negative 6. So it's like around negative 6 basically. So I'm just going to kind of put a big old dot at negative 6. Because it's basically negative 6. And then this other one, a is less than or equal to, and that's going to be a positive. 63 divides by 9 evenly. And that's 7. So it's in between those guys. All right. And then we here have 7x plus 4 and 74. 7x plus 4 less than or equal to negative 74. Okay, actually, let me make this a little bigger. Yeah, you can probably see that a little better now. Okay, so we want to subtract 4. I would get 70 there. And then over here, if I subtract 4, it gets bigger. Then I want to divide by 7, so I'd get 10 here. That goes in nice and evenly. Also, I've been noticing a pattern. I don't know if you caught this, but it seems like lately we've been getting one answer that goes in evenly and the other answer that doesn't, with number 8 being the exception to that rule. But, yeah, because we subtracted by 10 there and then added 10 there. And then that ended up going evenly for number 8. But every other question in this last set of 4 here, one of them goes in evenly and the other one doesn't. Kind of weird. But negative 78 over 7 would basically be, so I'm going to put a little squiggly here, which means like approximately. If this was negative 77 and I divide by 7, it'd be negative 11. So I'm going to put negative 11 just because it's going to be easier to graph that on the number line. But technically, you would just leave it if you wanted the correct answer. You would just leave it as negative 78 over 7 because that doesn't simplify. Okay, so I'm just going to leave it. Negative 11, that's going to be like right here. Negative 8, negative 12, so that must be negative 10 right there. So negative 11 is going to be like right here. Including, has to be less than. Notice this sign is a greater than sign. when it's that greater than sign, it's going to be or. And then here's 10 going this way. All right, rounding off the rest of these now. So let's go ahead and switch colors again. Switching to yellow. And notice these are a little different. So I'm going to go I'm going to not go, super fast on these, but I don't have the absolute value completely by itself. These are kind of a different class of problems. I'm going to end up doing them the same way as I did on the first page. But I have to solve for I wanted to say inequality, the absolute value first, before I split it into two equations. So here's what I'm going to do. N minus, I'm just going to copy it over here. So I have a little bit of space. I want to add 3 to both sides first. If I add 3 to -2, it becomes +1. Then I can split it. Keep it the same. Keep, change, flip. So I solve for the variable up until the only thing left on the left or right-hand side is the absolute value marks. Then I split it into two things, and then I keep going if I need to. Here I don't need to because once I split it, it was already solved. So we're good. But yeah, so at this point, n is greater than 1. Okay. So open circle, greater than 1, and less than -1. Okay. So really, n can be a lot of things. It just can't be like 0. Because the absolute value of 0 would be 0, minus 3 is -3, which is not greater than -2. So there we go. So we solve it a little first. Add 6 to both sides. Right? So add 6 to both sides. Plus 6, plus 6. So then it would be absolute value of k is less than or equal to +5. So then we write it the same. Keep, change, flip. Less than 5, less than or equal to 5, and then greater than or equal to -5. So it's right here. There we go. All right. Next, go gold. Gold next, and then orange. So let's see if we can fit this down here. So we would go absolute value of n less than, and we'd subtract 4 on both sides, so 8. And then that splits into this, and it splits into keep, change, flip. Okay, so greater than -8, less than 8. Here it is. All right, not so bad so far. It'll get a little more complicated as we go, but this is not so bad. We just subtract 7 on both sides. I'll show the in-between step on this one, since there's really only one step, and then once you split it, you're done. 16 minus 7 is 9. So then this would just be x greater than 9 and x less than -9. So let's see. -9 is like right here. And then greater than 9, which is like right here. You would think it would be the next bar over, but the bars are going by 2s, which is a little deceptive there. So be careful with how they word how they put the number lines and how they put the bars and the dashes on number lines. Your teacher might try to not be so tricky, but on here, some of these number lines are a little tricky. You have to make sure you're reading them properly. Don't miss the question because you didn't look at the number line. It's a lot of little things that you can miss here. So be careful. So we want to add 3 to both sides here. Okay. So then p is less than or equal to 3. P is greater than or equal to -3. -3, 3, it's in between. All right, again, so this is starting to get a little repetitive here, so that's just 4, and, oh, I put a or equal to on there. Trying to go a little too fast for my own good. Greater than -4. -4, +4, it's in between, just like that. All right, these are all fairly easy so far. It's starting to ramp up a little bit now, though. So let's see here. We'd have to subtract 10 on both sides. So b minus 8. Subtract 10 on both sides. So that would be greater than 12. All right, subtract 10. Then we split it. So keep it the same. And then we have keep, change, flip. All right, we want to add 8 to both sides. So that's 20. Add 8 to both sides of this equation as well. If I add 8 to a negative, I'm actually subtracting. So 12 minus 8 is 4. That's negative 4. Negative 12 plus 8 is negative 4. Always be careful with integers. They are not to be underestimated. There's negative 4. So it says less than that and greater than 20. All right. Also be careful. If it has a negative, if you end up solving it just before you split it, if there's a negative sign just before you split it into two equations, then your answer is either all reals or no real solution. So it's either the whole number line or none of it. It's all or nothing. If there's a negative right before you split up the absolute value. Okay, so keep that in mind. That'll save you some hassle. I don't think that's coming up right now, but it probably will at some point. I'm going to multiply both sides by 5 here. So this is x minus 4 less than or equal to 10. Then we split it. X minus 4 less than or equal to 10. Keep, change, flip. Add 4 to both sides. Add 4 to both sides. And so greater than or equal to negative 6. Less than 14. Right, less than or equal to 14, that is. And that's it for that one. All right, next color. We want to add 3 to both sides here. So n minus 2. Add 3 to 5, I get 8. Oh, forgot the absolute value marks. There we go. So then we want to get rid of the absolute value marks. Keep, change, flip. Add 2 to both sides. Add 2 to both sides. S is x, sorry, n. Said x wrong, but it wasn't even the right letter. N is less than or equal to negative 6. So that's right here. I think I said less than or equal to, sorry. Less than, strictly less than. And then x is greater than 10. All right, that's supposed to be an open circle. All right, times it by 7 on both sides because it is being divided, so opposite operations. So absolute value of 3 plus r is less than or equal to 35. Then we split it up. 3 plus r, less than or equal to 35. Keep, change, flip. We want to subtract 3 on both sides. So 32. Subtract 3 on both sides again. Negative 38. Greater than or equal to negative 38. It looks like these go by 5s. So negative 38 would be like over here somewhere. And 32, so that's going to be right here. They did not do a good job on this. It looks like, oh, I don't know why it did an arrow, sorry. We would not do an arrow. It would just be what's in between. I almost want to say arrows because it looks like it's the whole number line, but it's not. It just starts and ends like right on the edges right before you get to the arrows. But it's not all reals. I don't know if we're actually going to end up talking about all real solutions here because we just got to the end here. We're at the end, the last 2 questions. So I might just make up a quick scenario where that would happen so you can see what I'm talking about. But I'll maybe add that in so you can see what that looks like because that would be a trick question. Like if you ever get like extra credit questions on tests or quizzes or whatever, that might be something your teacher would throw on there. Or maybe they just are going to talk about this next after they, go over this worksheet with you. I don't know. Split it up. 10. And then we want to do keep, change, flip. Subtract 2 on both sides. That's 8. Subtract 2 on both sides. So, or sorry, did I put a 3? I did put a 3 there. Oh. Glad I caught that. See, everybody makes mistakes. You just got to be able to catch it. You just got to be able to check your work and whatnot. I don't check my work on all of these because, it's, being recorded and I'm putting it on YouTube, and I don't want to like bore you with checking every single answer. But on a quiz or a test, you definitely want to check these. So that's why I sometimes say in the videos, like, if I messed up, let me know. Because sometimes I just, don't realize. I'll just be like, oh yeah, this is the answer. So let me know if I missed something. X is going to be less than or equal to -4 here. And then here it's just 8/3, which is a little less than 3. Because 9/3 is 3. So, little less than 3, greater than or equal to a little less than 3. Little less than 3 right here. And then right here, less than -4. Less than or equal to -4. Okay, so it goes like this. Which is fine, because it's greater than. When it's greater than, you're going to end up with that or thing, right? So, subtract 8 on both sides. So 8 from 17 is 9. Then we split it up. Keep the first version the same. The second version is keep, change, flip. Then we want to add 7 to both sides. Add 7 to both sides. Divide by 4. V is less than or equal to -1/2. Divide by 4. V is greater than or equal to 4. Here's 4. -1/2 is going to be like right here. And there we go. There's that solution. All right. So that is all of the questions on this worksheet. But don't go just yet. I want to show you one more thing. I just was mentioning earlier that sometimes you get this thing where like you end up with this solution that just doesn't work out. So let me put this down here in the solution area. And by the way, if I went too fast, let me scroll a little bit and just pause it if you need to see one of the answers or solutions or whatever, and check it if you're not sure I did the work right. Here's the answers. Okay, so I'm going to go up to the front here. I'm going to kind of ignore the answer stuff. And I'm going to just kind of show you what I mean by all reals or no reals. Okay, so let's say the absolute value of x is less than -3. Okay, so if you just try to solve this, it will actually algebraically seem like it works. Because I would do this, keep it the same, and then keep, change, flip. Right, so I end up with these two answers. Now on a number line, -3 is right here, so it'd be less than that. And then +3 is right here, so it'd be greater than that. So you're just like, oh, that must be the answer. It has to be less than -3 or greater than 3. Boom, done. But wrong. Wrong. This is where it's tricky, because right before you split it, you need to check. If you have a negative, the answer is actually going to be all reals or no reals. This, I'm going to use red here, this is not the answer. X, no matter what it is, has to be, after I take the absolute value, a positive number, or 0. 0 is sort of like both positive and negative, or neither positive or negative, depending on how you look at it, I guess. So 0 is the smallest number possible after I take the absolute value of x, right? If it's a big positive number, it just stays the same. If it's a big negative number, it becomes positive. So the smallest number possible would be 0. But 0 is still greater than -3, not less than -3. So there's no value of x that's less than -3 after I take the absolute value. So there's actually no solution. So let me use green. There's no solution. Right? This is what you would want to put for the answer. No solution. You just leave the number line alone and write no solution. Or if your teacher's okay with this, a 0 with a slash through it, which is a really short way to say there's no solution, basically. Okay. And that would be all you'd have to do. So that's why I was saying earlier, check to make sure when you get to the end, right before you split it up, right before you split up the absolute value bars into two equations, two inequalities, make sure you check for that negative. Otherwise, you're going to get the answer wrong, even if it seems like you're doing all the math right. All right, so that's really tricky. Really, really tricky. So that's why I wanted to warn you about that, okay? Here's the other version. Let's say x is greater than negative 12 or something, right? So remember, same thing happens. If I take the absolute value of x, the smallest thing that I could possibly get out of that would be 0. If x is negative, it becomes positive. If it's positive, it stays positive. The smallest thing would be 0, which is greater than negative 12. So any value of x is greater than negative 12 because absolute value always churns out a positive answer. So the answer would be all real numbers. All real numbers. You can sometimes put all real numbers like this, ARN. And then if you want to, you can fill in your number line. Right? So if they give you like a standard, black colored number line or whatever to shade in your answer, just shade in the whole number line with your pencil or whatever, right? So that your teacher can see like, oh, it's the whole line. So make sure you shade in that whole thing. Just go crazy shading in that whole number line and put all real numbers or all solutions. Or if your teacher told you to put something else that sounds like what I just said, then obviously go with that. But if she didn't specify all real numbers, ARN is probably the simplest way to write that. ARN. Or infinity. You could put the infinity sign right here. Yeah, that would work actually. So, ask her just to be sure. Ask her, ask him, whoever, if that's okay. But here's a couple extras, a couple things to be wary of that you might run into. Okay, so a little extra in this worksheet. I didn't just go through the worksheet, but here's all of the work. In case you missed anything, you can either go back or you can check out what I just did there. You can pause it, go back a little bit to look at that answer. I'll also save this document. So if you want this document, you can just email me. My email is in the description below, along with what the video is about, what the whole playlist is about, how to contact me for tutoring, that sort of thing, and my free guide, The 5 Math Mistakes Everyone Makes and How to Avoid Them. And with that, I'm off, and I'll see you in another episode real soon.